SQL Server Big Data Clusters incorporates two external technologies, Apache Spark and Hadoop distributed file systems. It's probably worth spending a few minutes discussing what these actually are and how they support Microsoft's vision for big data clusters. First, we should probably ask, what is big data? The term doesn't refer to the size of a database. Big data is fundamentally different than the relational data stored in SQL Server. With the explosion of the Internet of Things and today's always connected devices, companies are collecting data at rates unheard of just a few years ago. Much of this data isn't just text either. It's video, it's audio, it's images from cameras and sensors, and all of it is unsuitable for storing in the traditional relational model that SQL Server was built around. Further, it's the analysis of this flood of information that brings value to the data. Radar and camera sensors built into a self-driving car are useless without some sort of machine learning algorithms to process all of that gathered information to get passengers safely to their destination. Without analysis and statistics, all of the data just becomes a stream of useless noise. Together, all of this information and the analysis that gives it meaning are lumped together under the umbrella of big data. Because of the rate and volumes that big data is collected in, new approaches to storing and querying that data are required. That's where the Hadoop distributed file system comes in. With HDFS, hundreds or thousands of inexpensive servers running commodity disk drives work together to spread the load of quickly saving and retrieving data files. Redundancy is built into the system, so portions of the same file can be retrieved from multiple servers simultaneously through parallel operations. And fault tolerance ensures that information is available even as disk drives fail and get replaced. What HDFS does for the storage of big data, Apache Spark does for the analysis of it. Apache Spark manages distributed scalable compute resources to quickly process data stored on the Hadoop distributed file system. It does this through efficient in-memory caching and by reusing data across parallel operations. Using Spark, data scientists can leverage the extensive libraries of the Java, Python, Scala, or R programming languages to process and analyze the data stored in HDFS. In a big data cluster, we have HDFS and Spark to store and process high-volume data. And they sit right alongside SQL Server for storing and processing high-value relational data. Big data clusters bring one more trick to the party, and that's to enable SQL Server to read and write directly to the same HDFS data stores that Spark uses. Both SQL Server and Spark can read and write to data stored in either native HDFS Parquet files or plaintext CSV files. This creates a single shared data lake. Applications and analytics querying the data from the SQL Server master instance or Spark jobs can all simultaneously query the data and get the same results. And users can choose to use whichever tools or programming languages best meet their needs, regardless of whether they're analyzing relational data, big data, or a combination of both.